And now this question is asking us to calculate the value of Kp for the equation this. So we just wrote it out. It's going to look like carbon plus CO2 gas is equal to 2CO gas. We don't know the Kp, so there's the K for product, how much product is being produced here. But they do give us two formulas here. They give us carbon plus 2H2O turns into, well, just use that formula because there is a K value. Okay, CO2 gas plus 2H2 gas, and the Kp for this one is 3.53, so that definitely favors product being produced. Now the second one is H2 gas plus CO2 gas, okay, goes to H2O gas plus CO gas, and that would be Kp2 is equal to 0.699. So this one is kind of more reactant favored. So the way you solve for these questions actually is that you want to go through a process of multiplication, as you add equations, you're really multiplying them together. You're multiplying their K values, okay? But first we need to actually get to this equation here from these two given. So let's look at it. Okay, we have one carbon, okay, so that's good throughout the whole thing. So most likely this equation here is going to stay as 1. We don't want to touch it. Okay, so now we look at the other components. It says it only has one carbon dioxide. This one has a carbon dioxide here, but this one has a carbon dioxide here. At this rate, these two would cancel each other out, meaning that our overall reaction would have 0 carbon dioxide. And the last piece here is that there's CO gas, carbon monoxide. This one has only one carbon monoxide gas, and it needs 2 of them. And if you notice here, when you go through the rest of it, this right now would lead to 1 extra hydrogen gas being produced and 1 extra water in the reactants. So what I did here actually is that I noticed that by trying to not simplify but cancel each other out, I need to multiply everything here by 2. Okay, if I put a 2 in front of everything, you notice then that things start canceling each other out. 2H2, bam, gone, no longer in our final equation. 2H2O, also no longer in our final equation. 2 and 1, so this is going to be -1, and this one gets canceled out. So overall, when we put in our final equation, okay, we now have the same as the above, right? But what happens to the Kp value for this? Remember, when you add an equation, you multiply it. So what we've really done here is that we've squared it, because we added the second one of it, so then we multiply it by itself. So now that Kp is going to be 0.699 squared. And don't forget the first equation we use is going to be multiplied by the 3.53. So I hope you're following, because first we balanced out the equation, and based on the fact that we had to use 2 of them, we multiplied this Kp by itself, hence how we got the squared, and then we multiplied by the first formula since we still have to add that one in. So overall, this is going to be our equation to find Kp. And when you plug that into a calculator, what you get at the end is that Kp is equal to 1.72, and that would be our Kp for today. Let's see how we did. So they have the equation, first one, second, and third one, and then first what it is, they balance it out. Interesting. It definitely did a very strange way. But what it did overall, because of the little signs here and there, it's hard to read. But what it did overall, I can see is that they ended up with the same balanced equation of this, which is what we wanted. Okay, and they did say exactly, so Kp 3.53 times 0.699 squared, and that's how they got the 1.72. So this is indeed correct. And let's go over to the